Wow. I was wondering who that was. I thought it was Kales. Okay, come on, Google. Google. Okay, here we go. Okay, document camera. Okay, so page 807. So what I want to show you, I'm not going to spend a lot of time, but there are different ways to represent data, which you may see on the STAR test. I don't think they'll make you create it, but you need to recognize it and be okay with it, okay? So the first one, which you've seen already, is what's called a dot plot, right? And for example, in this situation right here, here's some data, and here's a table which you're used to seeing. So this is the number, and then this is just the tally, right? So if you're looking at this data here, right, you would just normally go, okay, I've got 2 zeros, I've got 6 number 1s, I've got 4 number 2s, I've got 3 number 3s, and I have 1 4. So with a dot plot, what they did is they took this table and they kind of took it and flipped it on its side like this, right? So here's 0, 1, 2, 3, 4. And then they just changed the tally mark to a dot, right? So 0, I have 2 dots. For number 1, I have 1, 2, 3, 4, 5, 6. For number 2, I have 4, 1, 2, 3, 4. For number 3, I have 3, 1, 2, 3. And for number 4, I have 1. So this dot plot is the same representation as this table, right? They just took and just flipped it like this, so it just looks different. But it's just another way to represent the data, okay? So if we turn the page, one way to give a picture of data is to make a dot plot. A dot plot is a visual display or distribution of data values where each data value is shown as a dot or other mark, sometimes an X above a number line. A dot plot is also known as a line plot. So something like this. Okay, so this is called a dot plot or a line plot. Okay, that's one representation. Okay, so now let's jump to 815 in your book. Okay, and there is this diagram called a stem and leaf plot. Okay, we're not going to go over this. I want you to turn the page. Okay, so here, let me see. I'm zoomed in. So you can use a stem and leaf plot to organize large data sets so they are easier to interpret. This is their opinion. In a stem and leaf plot, the data are ordered from least to greatest and organized by place value. Okay, so let's see how they did that. So here's this data, right? Here's all this data. And it says step 1, draw a vertical line and write the tens digits from least to greatest to the left of the line. So what they did was they drew this line like this, right? And they drew this line. And what they did is, if you notice your data, right, you have 2 digits. You have your tenths place and your ones place, okay? So all the different tenths place that we have represented in this table is like, see, that's a single digit. That's the ones place. So we have what's in your tenths place is a 0. So we have to put a 0 here. And then you have some numbers that have a 1 in the tenths place, like 12. And then you have to have a 2 because these numbers have 2 in the tenths place, and then 3, and then 4, okay? So this is going to represent the tenths place for these different numbers in this data set. So then since the least value is 2 and the greatest value is 45, the stems are 0, 1, 2, 3, and 4. So this is the stem part, which is the 10th place. So if you think of that as the 10th place, and this is the ones place, write the ones digits in order to the right of the line with the corresponding stem. The ones digits form the leaves, stem and leaf. Each leaf represents one data value, so representing values are each represented. So we're going to take each one of these pieces of data and represent it in this stem and leaf chart. Okay? So for example, if I was to represent 2 in my stem and leaf, I would have a 0 in the stem because there is no 10th place, and I would put a 2 there. So this represents 2. Number 3, I would have 0 in the 10th place and 3, 5, wherever 5 is, 0 and 5. 7 would be 0 and 7. Okay? Now let's go to ones in the 10th place. So I'm going to find all my numbers so I have a number 10 here. So, right, I'm going to put a 1 here that represents the 10th place. And I have a 0 in the ones, right? So that represents 10. You're kind of sharing this 10th place, right? So you don't have to write it. So then we have a 12, right? So that's going to be 1 and a 2. 12's right here. And then we have a 14. So 14 would be 1 and a 4. And then a 17 is 1 and a 7. And that's the way the rest of this works. Okay. So the last step is include a key that explains the stems and the leaves. So this is your key here, right? So this is your 10th place. This is your ones place. Okay. So this is what is called a stem and leaf. Okay. You may see this on the test. I don't think I don't know. I can't remember whether I've seen one on the STAR test or not. Okay. I do not think they would make you create this, but they may want you to collect data. Like they may say, find the mean for this set of data. So you would have to know how to recreate that so you could create a mean or solve the mean. Okay. Okay, that's stem and leaf. Okay, then we're going to jump to 827. Okay, and this representation is called a histogram. Okay, so let's turn the page and we'll just read about it. Okay, so the data from a frequency table can be represented as a histogram. A histogram is a type of bar graph used to represent numerical data that have been organized into equal intervals. So they've been grouped together in different groups. Okay, they're not grouped by individual numbers, but by groups. Okay, these intervals allow you to see a frequency distribution of the data, or how many pieces of data are in each interval. So if you look at this example here, right, if you notice, you have numbers of airplanes here, and you have the prices here, but it's in a range. So it goes from $25 to $49.99, or $50 to $74.99. So you have a very wide group that can fit into that data set. Okay. So there's no difference. There's no space between these bars because all the intervals are equal. All the bars have the same width. And the intervals of the frequency of 0 have a bar height of 0. Okay. So if we have no data to represent that, it's just blank. Okay. The scale of a histogram includes all numbers in their data set. The intervals should organize the data to make it easy to interpret. Okay. So this is just a type of bar graph. This is called a histogram. And what's unique is that each bar is a range or a wide group that fit into that. Yes. Sure. Okay, so that is a histogram. Last one, 835. This is called, and we're going to skip this page. We're just going to read about it. This is called a box plot. Okay. You may very well see this on the STAR test, but they'll mainly just ask you a question about it. I do not believe they would make you create it, but they want you to be able to recognize it. Okay. So a box plot or a box skin and whisker plot, and why they call it, like if you were looking at a dog or a cat straight on, right? This would be their face and this would be their whiskers, right? The whiskers stick way out, right? That's why they call it a box and whisker plot, okay? So use a number line to show the distribution of a set of data by using the median, the quartiles, and the extreme values. A box is drawn around the quartile values, and the whiskers extend from each quartile to the extreme data points that are not outliers. The median is marked with a vertical line. The figure below is a box plot. Okay, so if you notice on this diagram here, right, here is your number line. So here's your data. This box here represents the bulk of your data points right here. This is your median. Okay, this is your Q1, the top end of your Q1. This is the bottom of your Q3. Okay, and all your numbers fall into this. So the bulk of your data is right here. You may have a number that is outside of this main grouping, which is this point right here. Okay, and then you can have actually a data point that is way out in left field. It doesn't even get close, and that's what's called an outlier. It's just not a part of your data. It's something that you acknowledge, but it's something that you don't use because it would skew your data. Okay, if I took that and threw this in for an average or a median, it would skew all this way. And you don't want to do that because the bulk of your data is right here. Box plots separate data into 4 parts. Even though the parts may differ in length, each contains 25% of the data. The box shows the middle 50% of the data. So this is the middle 50%, right? This is showing the other 25%, and this is showing the other end of the 25%. Okay, it's just a way to represent it. You will learn more about statistics in high school, more in college, okay? It's just a way to interpret data and look at data. Okay, so I just want you to recognize these so you know what they are, that they represent data, and they have different qualities that help you to represent the data, okay? So now let's set you up for the quiz, okay? So the quiz has 1, 2, 3, 4, 5 questions on it, and it's on 3 different pages. Okay, so the first page, and it's in your Google Classroom what page it is, so you need to pay attention. So the first page is 790. So if we go to 790, okay, so here's 790, and let's write at the top, you're gonna, just so you have it, you're gonna have you have a total of 5 questions. You're gonna have 2 questions on page 790. You're going to have 1 question on page 798. And you're going to have 2 questions on page 806. 2 on page 806. Okay? Just as a reminder, you're going to have 2 on 790, 1 on 798, and 2 on 806. That's also on the Google form, but just in case. Okay, so the first question is on page 790. It's number 12. Okay. So reading the question, it says the dot plot, which we have here, shows how many minutes Mr. Elliott's piano students said they practiced on the day before their lessons. I have no idea what Malaya practiced 31 minutes, but forgot to tell Mr. Elliott. If Malaya's time were included, by how much time in minutes would the mean, right, or the average it increase? Okay. So you have to find the mean twice, right? You have to find it once without Malaya's time and once with Malaya's time. Okay. So if we have mean number 1, right? We're going to look at all your numbers on your data, right? So you have 2 12s, you have 2 15s, 3 16s, and 1 20, which you're going to have to add together. And how many data points do you have? 1, 2, 3, 4, 5, 6, 7, 8. So you have 8. So if we represent that, that's 12 plus 12 plus 15 plus 15 plus 16 plus 16 plus 16, because we have 3 of those on our data plot, and 20, right? We have 20 right here. So we're going to add all those up, and we're going to divide by 8. Okay, that's going to give you the mean without Malaya's 31 minutes. Okay, then you have to find mean number 2, right, which we're going to add to this set, right? And if we continue the number line, it would be way out here, 31, with a dot on it, right? So now we're going to have to add 12 plus 12 plus 15 plus 15 plus 16 plus 16 plus 16 plus 20 plus 31, right? So then we're going to divide that by, not by 8 anymore, but by 9, because we have a whole nother data point. So we have to divide that by 9. Okay? So then when you get your 2 numbers, you're going to take mean number 2 minus mean number 1. And that's going to give you your answer. Okay? Okay. So that's 12. 13. The graph shows how many rides a group of friends went on at the fair. Each ride cost $2.75. What was the mean amount of money in dollars spent by per person to go on the rides? So the first thing you have to do is find the mean for the number of rides for the friends, then multiply that by 275, right? So your mean, right? You're looking at your data set here. This is your data. This is the number of rides each person rode. So your mean is 6 plus 4 plus 7 plus 6 plus 4 plus 3. So you have 1, 2, 3, 4, 5. You have 6 friends. 1, 2, 3, 4, 5, 6. So you're going to have to add that up, and you're going to divide that by 6. That will give you your mean. So you're going to have to take this. I'll just put N for number. You're going to take your number times $2.75, and that will give you your answer. Okay? Okay, I'm recording this, so I'll post it. So don't get stressed out. You'll be able to watch it if you need to. Okay. So that is page 790. Now we're going to go to page 798. Okay. 798. And 798, it's number 14. So we're going to circle 14. Okay, so that's down here. Okay, so the question is, what is the difference between the medians? And if you remember, median means middle, right? So this is the middle of the data, right? So of Kendra's sprint times and Hakeem's sprint time, okay? So we have to find the median for Kendra, and we have to find the median for Hakeem, and then we have to subtract those two numbers, okay? So let's first do Kendra. I'm just going to put K for Kendra. So for Kendra, we're going to look at this data set because this is her data. We're going to have to put it in order from smallest to least and then find the median, right? So we have 11 plus 11 plus 12 plus 12 plus 13 plus 13 plus 14 plus 14 plus 14 plus 15 plus 15 plus 17. Okay. Make sure I don't mess up here. Okay. So the middle, we have to find the middle. How many numbers do we have? We have 12 numbers. Okay. So we won't have an odd number. So we have to count from both ends, right? So 1, 2, 3, 4, 5, 6. So that's right there. 1, 2, 3, 4, 5, 6. So it's right there. Okay. So we have to find the average. Since we do not have a unique number there, we're going to have to find the mean for 13 and 14 to find the median. So we're going to take 13 plus 14 and divide it by 2. And that will give us the median. Okay, that's going to give Kendra's median. Okay, now we got Hakeem's. So I'm just going to put H. So here's Hakeem. Okay, we've got 11. I don't have to put plus signs. I don't know why I'm doing that. 12. Then I have 13 plus 13 plus 14 plus 14 plus 15 plus 15 plus 16 plus 16. Okay, so this is Hakeem's data. Okay, well, he has the same quantity of times, right? So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so we're ending up right here. So we're going to have to find the mean for 14 and 14. So 14 plus 14 divided by 2, well, gives us 14, right? So that is the median for Hakeem. Okay, but it says, what is the difference between the two medians? So you're going to have to subtract, right? So you're going to take Kendra's median minus Hakeem's median. And that will give you your answer. Okay? So you did your number, you're going to find this median here. Your median here is 14. You're going to subtract that from that, and that will give you the difference between the two medians. Okay? Okay, that's 798. Now we're going to go to 806. This is the last page. Okay, so we have 2 questions here. We have number 13. And we have number 14. So 13, it says, Melissa is keeping track of the temperatures in her town at noon each day. She has recorded the temperature for 6 days so far. how much greater will the interquartile range be if Saturday's temperature is 70 degrees rather than if it's 58? So if you look at your table here, we're going to put 58 there, and we're going to put 70, and we're going to see if it's going to make a difference in the interquartile range, okay? So let's set this up. So we have to put the data in order from least to greatest, okay? So this is our first option, right? This is the one with 58. So if we put these in order, right, we should get 54, 58, 58. Then we have 60, 62, 64, and 72, okay? So we have to find, how many numbers do we have? 1, 2, 3, 4, 5, 6, 7, okay? So we're going to count and find the middle. 1, 2, 3, right? 1, 2, 1, 2, 3. This is the middle. This is the median, okay? But we're not looking for the median, right? We're looking for the interquartile range, right? Well, we know this is quartile 1 on this side. We know this is quartile 3 on this side, and we need to find the median of that quartile. Well, the median for quartile 1 is 58, and the median for quartile 3 is 64. Okay? So to find your interquartile range, IQR is equal to your Q3 minus your Q1. Okay? So that gives you your first interquartile. Now let's do it again, but with 70 in this place for Saturday. So if we put it in order from least to greatest, we're going to have 54. We're going to have 58. We're going to have 60. We're going to have 62. We're going to have 64. We're going to have 70. And we're going to have 72. Okay? Well, now let's go find the middle. Here's 1, 2, 3. 1, 2, 3. This is our median, right? But we still are interested in quartile 1 and quartile 3. So this is our median for quartile 1, and this is our median for quartile 3. So your IQR, interquartile range, for this set of data is again Q3 minus Q1, gives you this number, but then you're going to have to subtract these two. So we'll call this IQR1 and IQR2. Okay? So you're going to take IQR2 minus IQR1, and that is your answer. Kind of involved, right? Okay. This is the tricky part, just finding your interquartile range. Okay. Okay, last one, number 14. Wow, you're just going to get this done. Okay, Jamal cut out these shapes from the construction paper. What is the interquartile range for the areas of the shapes? Okay, well, first you have to find the area for each one of these shapes. We have 4 different kinds of shapes. Okay, to find the area of a square is length times width, right? The area for a parallelogram is base times height. Area for a rectangle is length times width, right? Now I have a triangle. What's the formula for the area of a triangle? It's 1/2 the base times the height. So now we got to find the area, right? Well, 3 times 3, so that's 9. The area is the base times the height. 4 times 2 is 8. Length times width, 6 times 2 is 12. And my triangle is 1/2 the base times the height. Well, my base is 5. My height is 1. That's 5. And half of 5 is 2.5. Okay, so I have my areas. So now let's see what I've got. Okay, so my numbers are from least to greatest is 2.5, right? I have 8. I have 9. And I have 12. Okay, so I only have 4 numbers, right? But this is the middle, right? So this is my Q1 over here. This is my Q3. Okay, so to find my Q1, my median, I have to average these two because this right here in the middle, right? So 2.5, so you're going to do 2.5 plus 8 divided by 2 gives you your median for Q1, right? And then you're going to do the same thing for here. So 9 plus 12 divided by 2 is going to give you your median for Q3. So then you're going to take Q3 minus Q1, and that'll give you your IQR. And that's your answer. Okay? Okay. So it's 2:03. There's not a whole lot of time left. Okay. I will post this video, so if you need to go back and watch it again, you can do that. Okay? Don't forget to check focus. I'll let you work on this for what little bit of time we have left, about 5 minutes. Yes, sir.
Okay. After I just need not really all these questions. I just need to like look at them. Probably so like or interquartile 1. I'm guessing is this one, and then interquartile 2 is this one.
Yes.
Okay.
All right,
I just needed some clarification. Okay, thanks.
yes.
And then
So so your Q1 is 58, and your Q1, I mean your Q3 is 64. So 58 minus 64 gives you this,
okay.
and then 58 minus 70 gives you this,
Okay.
and then you subtract those two.
Okay. Can you start?
Yes, ma'am. Absolutely. Hmm.
May I have some scratch paper?
Yes, sir. Absolutely.
Thank you.
Mhm.
Question.
Yes.
Before this question, does it matter which one for the IQ? Oh wait, it's IQR2 then IQR1. I just put that in wrong.
Yeah, you
Okay.
correct those two numbers from themselves.
Okay. So two questions. One, whenever you have like a remainder, like in this problem, whenever you have like a remainder of one, and there's already a decimal point that you need to put right there, do you just would you just get it?
And then what you're dividing 10.5?
Yeah, on this A plus,
Uh-huh.
then yeah.
Okay. So that would go, so 2 goes into 10.5. Yeah. Right. So that's 0. Then you bring down the 5. And then you're going to leave your decimal point there. You're going to add a 0 because 2 can't go in. Oh, yeah, 2 can go in 5. So it'll be 2. Yes. So it'll be 5.25.
Yeah, or 5.25. Or 5.25.
5.4 comes up to 10. It's because you have to have another 0. That's 10. And 2 goes into 10. So
Okay.
5.5, right?
Okay, yeah, and then right here. Yeah, but once you get both of the medians of those, you just subtract them, right?
Yes, you want your
Okay.
interquartile, so you're going to subtract
Okay.
this median from this median.
Okay.
Yes. Okay, wipe off your table and you may go. Can you wait outside, please, till they're done when they come out?
Wow.